Greetings, math friends. We're going to look at integrating this function from 0 to 3 and see what happens. We can simplify these terms by expanding the polynomial at the top and then dividing this term out to get a rework of this. So this is going to be equivalent to the integral of 9x to the negative 1 minus 30x to the negative 2 plus 25x to the negative 3 dx. Now we have to find the antiderivative for that, and we are going to generate a log here with this. So this is 9 log absolute x plus 30x minus 25x squared, and evaluated from 0 to 3. Now that we have this antiderivative, we should be plugging 3 into x, and then in this case plug 0 into x and subtract those terms from the first terms. But if you notice, in each one of these individual terms, if we plug 0 in, this gives us something that does not work in a classic algebra. This is going to return undefined for us. This is going to be undefined for us also. Dividing by 0 is typically one of those things that you expect not to work in a classic algebra, but also the natural log of 0 is not going to work for us either. So why is it that we can go through a process which should work in general, but fails to give us something that works here? All right, if we look at this function here, we see this graph. It is able to be integrated in parts of it, but as you can see here, if I integrate from 0 to 3, it's saying it's undefined. As we look over here, we see there is actually a vertical asymptote here. As we approach 0 from the right-hand side, this is shooting up to positive infinity. If we approach 0 from the negative side, it's shooting down to negative infinity. So we can't integrate across this region because we have this infinite discontinuity. To illustrate this, we can go over here and switch the integrand here from 1 to 3, and you see we do get a value here, so we're in here integrating instead of across this asymptote. So it's really important to recognize if the interval over which you want to integrate is going to work with the function that you're trying to integrate over. This is why it is important to understand what you're looking at when you go to integrate, what you're being asked. You have to make sure that the interval of integration is going to work with a function that you're given to actually be able to come up with an actual result for this. Hopefully you will find some mathematics that is interesting in your part of the world that you can share with others. Cheerful Calculations.